Friends, we are into the next session in the fourth unit. This is collision and collision resolution schemes. We know what is a collision. Collision is when two records hash into the same location. Suppose we take two records, let's say L1 and L2, and if they come to hash to the same location, then we say there is a collision. Collision is almost impossible to avoid, but we can minimize. So if there is a collision, what do we do? How do we resolve it? So these are collision resolution schemes. So broadly, there are two classes of collision resolution scheme. One is called open addressing schemes. The other one is called chaining method or chaining schemes. So we will see each individually. So under open addressing, we have these three: linear, quadratic, double hashing, and under chaining, separate and coalesced chaining. So let's see what is a linear probing. So here is a hash table. Okay. So the values of k and location calculated. Let's imagine we are using the modulus operation. So modulus with 7. So 7 modulus. We get the location 2, imagining the memory to be this way. And for each. So 9 goes to 2. 18 is 4. So 21 goes to 0. 24 goes to 3. Now comes 16, which also will hash and gift 2. So 2, when I look, it is already, there is a value already occupying, which means 9 and 16, they are going to hash to the same address in the memory here by location 2. So what do we do here? So when h of lk is occupied, L, the new value of L becomes L plus I, where I is the increment size of the memory. Of course, here for this implementation, we have just used linearly or numbers, numeric increment of 1. So 9 is occupied, and so we keep incrementing till we find a free location. So here 5 is free, so I occupy this location. So this is called linear probing. That means we just keep probing by the increment size of the memory till we find a free space and item is occupied. Similarly, when I search for this item, the same location. So I use a method to search where it would be. So if it is not found, then I keep searching till I find the item. Let's say 16. So that is linear probing. All right. As a disadvantage, in most of these methods here, we will have a problem with clustering. Means records tend to crowd around one area. For example, here, if this is a free area, they will all tend to crowd around here. So that is a problem of clustering. And the second, this is not a direct hashing. That means though it hashes to the value 2, so the record is not found there, it is elsewhere. So it is the location hashed and the place of the record do not really match. So this is a common disadvantage of most of these three cases. So that is linear probing. Okay, so here we will go to the next. Next is, right, same. We are going to the next method, that is quadratic probe. Okay, so quadratic probe is almost same like linear probing. The only difference is, so if h of k, L is occupied, let's imagine we are using the same method of division method of storing, hashing, then L of h of k is L is occupied, then the new value of L is L plus I square, where I is the increment size of the memory. We go by adding the square to the value. So again 9 here is occupied, 16 comes. Now look here, I have changed the memory space just for squaring. Okay, so the memory gap or the increment is by 2. So 2, when this all get occupied as before, but when 16 comes, supposed to be in location 2, 2 is occupied. So it will increment by the square. That means it goes, the increment size is 2, so 4, it comes here. This is also occupied, so it goes another 4. So 16, it gets stored here. So here the increment is, that means the new value of L is L plus I square. So by the increment of, by the square of the increment. So that is quadratic probing. And the third, next is double hashing, the last of the linear. Double hashing is nothing, the explanation is here. You can use a similar picture to explain it if you want. So let's say h of k, L, if L is already occupied, if there is a collision, then we will call on a second hash function. Let's say h dash, and we compute L dash, that is h dash of k, or the same value, okay, I mean on same record k. So let's say I get L dash. Then the new value of L is L, the previous, the first value plus the second value. So this will be the new location where the record k is going to be stored. So this is the double hashing, meaning using two hash functions. If there is a collision, the second hash function is called, otherwise it is not called. So these are all open addressing. As we said, the two biggest disadvantages, the addressing is not straightforward, or hash, the value location is not straightforward, or you can say searching is not straightforward because the location stored and hashed need not be the same. Second, there is a problem of clustering, as we said. Right. So these are all open addressing. Then we go into the next scheme, that is called chaining method or chaining schemes. So there are two methods here, separate chaining and coalesced chaining. So let's imagine these are the records that I have. Okay. And I'm going to use the division method for storing, hashing. And here, okay. So if I'm doing a division modulus with 7, you know, all these values will hash to the location 0, which means there is a collision. And these will all hash to location 2. And here's location 4. I've taken some example. So what happens here is each record hashed is linked together as nodes of a linked list and tied to the location hashed. So for example, 7, 14, 28 are hashed to the location 0. So they are linked and connected to the location 0. Similarly, 9, 16, 30 to location 2 and 11. So this is what is called a separate chaining. That means items that are hashed to a location are chained together and connected to its location. Okay, so if you want to, nothing but nodes of a linked list. So here is a structure of each node just given, and explanation is here. One disadvantage that happens here is always the links can be long and addressing is in a way straightforward, and clustering is avoided because they are linked together. So then the last is what is called coalesced chaining. So this is a combination of the linear probe and separate chaining. So here what happens is when there is a collision, they are linked, they are moved using any of the linear probe. Let's say I use a linear probe, that means L equal to L plus I. So I move to the next location. Okay. Now for example, 7, 14, 28, 7, 14, 28, because 0, so not, so they occupied the next location. So but they are connected together using the chaining method. All that hashed together. So they are in the same memory, but they are linked together using the chain. Similarly, 9, 16, 30 are to location 2, 9, 16. So not free, these are not free, so they are moved linearly to the location, but they are connected together. So these are individually hashed, so they are not linked. So this is a combination of both linear probe or one of the open addressing, you can use any method, and chaining method. So these are the methods used for collision resolution. One small word of caution, very often students mistake in this unit hashing schemes and collision resolution. Do not mistake. Hashing, we have seen what is hashing. This is collision resolution. So the two are totally different. Thank you. All the best.